Thank you very much. Good afternoon. Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Mehmet, Begen, as I mentioned in the introduction, and today we are going to talk about decision making with analytics. So this is the outline for the talk. We're going to see what analytics is. We're going to see why we are learning and practicing analytics, why it's important. We're going to see some applications, and then we'll see some techniques of analytics, and we're going to spend most of the time of the presentation for examples and sample projects. So we can get a sense of what analytics can do and how it can be useful for companies and individuals. So what is analytics? You may have already seen this, but under different names. So it has many different names in different contexts and different disciplines, such as management science, predictive modeling, use of big data for better decisions, decision making with data, operations research, quantitative decision making, industrial engineering, systems thinking, and many more. So, but how can we define it? How should we understand it? So, one-line definition would be analytics is the art of using data and models to obtain managerial insights. So the key here is models and data, and why we are using these things. We like to obtain managerial insights. A more sophisticated definition would be a collection of scientific methods of providing decision makers a quantitative basis for decision making at strategic, tactical, and operational levels. So it's also consists of collection of scientific and mathematical methods. So the way that I think about analytics is it's a way of thinking. It's a managing and doing things. It's a process. It's not one-time event, but it involves. So we always can do better by using analytics. And I think it's also an essential management skill, a vital functional area of a company, a source of competitive advantage. It is a discipline and industry. So if you'd like to find out more about analytics, I'm giving two links that could be useful. One of them is Institute for Operations Research and Management Sciences. It's the biggest professional organization for this topic, and they publish a free magazine every couple months, and you can read that as well. So then the question becomes why we are learning and practicing analytics. So the answer is simple, because everybody is doing it and they're getting it their competitive advantage, and it provides lots of value in terms of monetary and then also other competitive advantages. If you look at the industries, we see a bunch of almost everything, such as energy, sports, insurance, finance, healthcare, military, transportation, logistics, entertainment, manufacturing, consulting, service, technology, and medicine. And if you look at the companies, you see all the big names out there. Toyota, Disney. For example, Disney, they employ about 80 industrial engineers in their amusement parks and in their headquarters to plan for everything, from customers arriving to their parks, like their hotels, their pricing, their capacity management, their lineup management at the parks, and etc. Google, IBM, Cisco, Volkswagen, Procter & Gamble, and a few others. So, and I'm providing here 4 different information about why we are learning and practicing analytics. One of them is from Harvard Business Review, from article, and they said data-driven decisions are better decisions. It's simple as that. From a famous consulting company, Begen Company, from 2003, they said leading companies embed analytics in their organization. So if you want to be a leader, then you have to get into analytics. And recently, Jack Ma of Alibaba gave an interview to CNBC, and he emphasized the artificial intelligence, analytics, and statistics for future. So he recommended for young people to study these things if you want a good job for future. And in that article, you also see Elon Musk of Tesla and Eric Schmidt of ex-CEO of Google. They also mention why analytics is very important. And I also provide a link if you're interested for reading later from SAS. SAS is a big statistical and analytics company, and its name is Big Data Analytics, what it is and why it matters, for future reference. So what are some applications areas of analytics? So you may already seen them, some of it. Revenue and yield management. So revenue management is one of the probably most important areas of analytics. It's about pricing and inventory management so that you can maximize your revenues, such as airlines are always changing their prices, hotels are changing their prices depending on how many rooms they have and different seasons. For example, the hotels during the Hajj season will be very different than during a regular season. Scheduling, predictive modeling, forecasting, production and maintenance planning, data and text mining. So this gets also pretty big because nowadays companies use this data to harvest data from internet, such as Twitter or Facebook and other websites, to try to get user insights. So marketing will be replaced by analytics because instead of doing focus groups now, you can harvest millions of people's of data at the same time. So if you can do that, there's no need to do any focus groups anymore. Big data analytics, legal analytics, that's quite interesting. Recently, companies just started to do this. So they are trying to reduce the number of lawyers working in a company, and then they are providing the information by using algorithms so that you get the information you want before meeting a lawyer. You just meet a lawyer, but maybe at the end. So this will reduce the cost drastically. Supply chain management, vehicle routing and transportation, energy generation and transmission. So this could be all hydroelectric power or oil power, and anything that you can name it. From pricing to how much the capacity should be there, adjustments to it, and etc. So one of the big areas also analytics can help is under uncertainty. So whenever supply or demand is uncertain, analytics can help to build capacity and manage capacity and inventory management at the same time. So here are a little bit more examples, such as during the, for the supply chain area, we see Dell, Walmart, and Amazon. What they do is they simulate and optimize supply chain flows and reduce inventory and stockouts, because that's critical. If you have a customer which you cannot provide a value for, then they may go somewhere else. For customer selection, loyalty, and service, we see Hotels Hara, Capital One, and Barclays Banks. So what they do is they identify the customers with greatest potential for profit and increase the likelihood that they will want the product or service offering. So basically they are trying to retain that customer who will be having a good profit potential for future and retain their royalty. In terms of pricing, we see the car rental company Progressive and the Hotel Marriott. So what they do is they identify the price that will maximize the yield or profit. For human capital, this is also a big new area now. Human resources are also using analytics big time. We see sports teams here. What they do is they select the best players for a particular task or jobs, and they also decide on particular compensation levels. For product and service quality, we see Honda and Intel. So they try to detect quality problems in advance and they solve it before they get any bigger. So they use statistical methods to identify if the process is going anywhere above or below a certain level, and they act accordingly. For financial performance, for example, we can think of Verizon. They recently acquired a lot of other companies. So they better understand the drivers of financial performance and effects of non-financial factors in their organization, and they separate the effects and act accordingly. For research and development, we see a pharmaceutical giant Novartis and other technology companies such as Amazon and Yahoo. They improve quality, efficacy, and very applicable safety of their products and features. So we can extend this to quite many. I put the reference here if you'd like to read more about it. So what are some techniques of analytics? You may already seen this as well. Just give you a flavor of what this is. Mathematical modeling, data analysis and visualization, optimization, simulation, probability modeling, forecasting, prediction, statistics, game theory, and queuing theory. So queuing theory is basically the theory of lineups. So it's very relevant to banks, call centers, and any service industry. So maybe you've seen this movie or read the book, Moneyball. So it's about a baseball team, Oakland A. So here the question, Oakland A was a less fortunate team. They had less money and smaller budget, so they had to come up with some new ways of recruiting their players. So what they did is they used these statistics and analytical methods to find undervalued players, and they became very, very successful. They also developed new measures to measure the success of a player and the team. Another example, again, is from sports. So analytics is used big time in scheduling all the big leagues in the world, such as the NHL and also the football league and the baseball league. So the question becomes when and where each team should play with each other. So that's a complicated scheduling problem. How should each stadium charge for the seats? That's revenue management again. And depending on the time of the day of the week, and like the month of the year is going to be quite different prices. If you're playing with a more important competition, then you're going to be charged more prices. If you're playing at the weekend, the prices will be higher. If you're playing at the playoffs, then the regular season, then again the price will be higher. And which players should be recruited as before, and what should be the team strategy plays with other teams. So depending on the team that you're playing, you may want to change your lineup, your strategy to win. And also if you're playing a tournament game or a regular game, the strategy could be quite different. Google is a big analytics company, so they are using analytics in every aspect of our business. For example, their biggest product is the web search, and web search is an analytical model. It's basically a big Markov chain, and each time they improve it, the search becomes better. And other areas that Google use analytics in their investments, so they decide where to invest, such as driverless cars or something else. They have to decide what to do. And Google also using analytics big time in human resources. So they use artificial intelligence and algorithms to review the resumes and manage people. For example, they identify the performance of people, and they try to figure out if a person is not happy at Google, if they're not performing up to the standards, they try to get in advance and then take the necessary preventions. And they also recently, the advertisement on internet actually surpassed the advertisement on the TVs, and Google is a big player in the internet advertisement, and analytics is used big time to decide which websites to put which ads, and whenever you're visiting a website or something else, it determines based on your history of web search, it puts the most relevant ad to you. So they're also using analytics big time there as well. So airlines are big consumers of analytics. I think it's safe to say airlines couldn't survive without analytics since the 1980s. So they have a big scheduling problem. So they have to determine which routes to fly, which flight attendants, and which pilots on which planes. It's a really complicated problem because there are so many rules with they can't fly more than a certain amount of hours. If they fly a certain amount of hours, they have to take breaks for a day or two. So it's a really complicated problem. And another big area for airlines is revenue management. Again, the airfares. So what should be the prices for tickets. And they also decide on overbooking. So overbooking is a really important strategy for airlines. Suppose you have a plane capacity of 100 seats. So airlines know that on average, say 3% of the passengers will not show up. So if that's the case, they determine the optimal way of overbooking it. Maybe they overbook 4 people because they know that even everybody shows up, it's still cheaper in the long run to deal with those 4 patients, maybe put them on different flights or put them in hotels for a day or two, than actually letting the seats to go empty. And they figured this strategy working very well for them. Of course, you may have seen the United Airline disaster in the couple months months before ago, but that was a bad management. But usually overbooking works very well for airlines. And another big area is how to manage their loyalty program. So it's also an important area as well. So how to answer these questions? Then my response would be build and use analytical models. So here we have a business real world situation. We have a problem here in the real world, but we can't really change the system without making any big changes to it, such as the airline scheduling or hospital management. Passengers or patients may suffer when we are making changes and trying to find the optimal level of doing business. So what we do is we take this problem and put into the model world. So we say this is a conceptual model. We try to see how can we model the business situation in the model world. Then we engineer the model and make a technical model. So this is basically maybe a spreadsheet model, a simulation model, optimization model. It's a technical model where we can make changes. After we are happy with our model and we validate the model, we analyze the model and then try to get some insights. You know, what should the staffing levels be? Which schedule is going to work better? What prices will work better? So once we get the insights, then we translate back those insights into managerial insights from our model. And hopefully we will be able to communicate back our managerial insights to a decision. And once we make the decision, we are going to see an action and results. So, and then I call this is analytical circle. So we start with the real world and we go to the model world and come back and then act on it. So I'd like to talk about 3 different projects in the remaining time. So the first one is a logistics and production planning for a Canadian beverage manufacturer. And the second one is a security queuing analysis for Vancouver Airport. And third one is managing surgical wait lists for a Canadian health authority. So there are more projects and more papers, and they are available on my website. And some of the projects have a 1-page description. So if you see something interesting, you can click on and read on it. So let's start with the logistic and production planning for a Canadian beverage manufacturer. So the company was producing, distributing, and selling beverages, and during the time of the project, they just entered a very competitive and a new market in the United States, and they had a really high seasonal demand. So their demand in the summer was maybe 3 or 4 times more than what the demand was in the winter. However, they had a lot of challenges. So during this high season, they faced lots of stockouts. So that's not very good, especially if you're new into the market, people trying to buy your stuff and then you can't provide the goods. They had a bad forecast, so the forecasts were not accurate. And they were also struggling with transportation costs. So they were trying to figure out what will be the best way to send goods from one place to another. Is it by full truck or train and other alternatives? So what they were hoping is they needed some sort of what-if type of scenario analysis to determine what will be the cheapest way to run their business. So let's look at the supply chain network. So here at the top, we see co-packers with, these are shown in green. So co-packers are basically production facilities. So these facilities are not owned by the company, but they were rented. They were renting the time for it. And distribution centers they were renting space for it. So you can produce something from this facility and you can send to certain distribution centers. And there are rules that you can't send everything from everywhere. And distribution centers are also capable of sending goods between each other if necessary. And the squares are basically, you can think of like states, and each triangle is basically a customer. So this project basically focused on the first 2 stages, production and distribution center, and the model can be extended to include these guys as well, but we basically took these demand as given. So the objective was trying to figure out what will be a good production schedule and inventory management schedule. So, or more precisely, enhancing the performance of the company's inventory distribution system using computer-based optimization models. So more precisely, we have to determine the production levels and allocate this production to distribution centers, determine if distribution centers sending anything between each other, and determine what should be the inventory capacity levels at distribution centers. And the second objective was trying to put this into a software tool. So how did we do it? We did it in 3 different phases. In the first phase, we started with a simple model. So we just took some products, we tried to understand the system and challenges, physical flow and information flow. We try to understand the timeline of the decision-making process, what day of the month the orders come in, when do we need to give the orders to the production facilities to start production, etc. And we use this model to prove the concept to the company so that we can get approval to do the second phase and third phase. In the second phase, we extended the model. So we included all the co-packers, which means all the production sites, all the distribution centers, and all the products. We also included all the necessary variables and business constraints. We omitted those constraints in the first one, such as if you are a certain production facility, you cannot ship your goods to this state. There were rules around it so that those rules have to be obeyed. And we also validate the model in this thing. I'll talk about it a little bit later. And in the third stage, we developed a tool. We call it ALOT. So it's AGA-grade logistics optimization tool. So it was an operational and tactical planning tool, and it was built in Excel, so it was easy to use. Everybody knew how to use it, and it connects with the systems very easily. So what was the analytical model look like? It was an optimization model where the objective was minimize the total cost. So what the total cost consists of: production cost, transportation between distribution centers, and inventory cost. So whenever you are putting something into the distribution center and getting out and holding it, you have to pay some cost. We had constraints. You have limited production capacity at each production site. You can only produce certain type of products at certain sites, and there are rules with transportation, and also distribution centers have their capacities. We also include some optional constraints in case the company wants to see the effects of it, such as in order to get business, sometimes you have to give some minimum production, guarantee minimum production levels at each production site. And also, since the forecasts were so bad, inaccurate, we came with the idea that why don't we carry 1 month of extra inventory to just make sure that we don't have any stockouts, and what will be the cost of it? So the model can actually find out the cost of carrying 1 month additional inventory, and you can carry 2 months, 3 months if you want. So how did we validate this model? So one thing about analytics is it's great to build models, but the models should be accurate enough so that it's going to make sense for you to use in the real world. So we have to validate them. How did we do this? In this case, we showed our model to the experts in the company. So we had lots of site visits. We used the model with them. They tried their alternatives. They tried their current schedule and then compare what the model gives. We had training sessions and lots of meetings. And we also built the same model with a different software and compared 2 different models. And they were matching quite nicely. So this is a picture for the model. So it was built in Excel at that time. I think we had over 16,000 decision variables, lots of constraints, but Excel were able to handle it with the additional software. So the reason that Excel was used is because the company didn't want to invest in another software at the time. And also they think that the people will be easier to start using this software first. We built some user interface for it, and then we gave the guidelines how to use it. Here on the left-hand side, you are basically inputting the data, all the data that you have. These are buttons. You click on it, and then the picture comes in. You can copy and paste your data or get from another spreadsheet. Then here you solve the model. You can check the constraints that you want. Once you click solve, the model works 3 minutes, solves the optimized schedule, and then you can actually read your plan, production plan, distribution plan, etc. And the model also had a small user manual that you can get into if you have any questions about it. And then what we did is we look at how should we implement this. So we came up with the idea of rolling horizon process. So what this is you each month you solve the model for the next 12 months, and next month you solve it again for the next 12 months. Since the forecasts were not accurate, but the forecasts were more accurate for the next month than for the next 12 months. So each time you are doing this, hopefully you are converging a better production plan. So we said just one month before, about 20th of the month, you provide the forecast for the next 12 months. And in this month, about the 5th day, you estimate the closing inventory. You determine the opening inventory, production schedule, actual orders. So we give them a recipe how to implement this model at each month at different days of the month. And the models actually worked very well. So the network was about $100 million US, and the model saved about 5%. So that was quite significant, and they were very happy about it. Besides these savings, there were also interesting business applications. When we were building this model, there was a negotiation between the production facilities. So what happened is one of the VPs took the model with his laptop, and then during negotiations, he saw different scenarios and then came up with different pricing. So one side benefit of using optimization model is it can determine the best production site overall. So a production site may have a low production cost by a high transportation cost, and depending on where it is, the overall value may change. And optimization model is providing a side product called shadow prices, which determines the value of that production facility. So the higher the shadow prices it's more valuable. So that means if you could have one more extra unit in that company, then your profit will go up by that price. So by looking at the shadow prices, then you can see which production site is the most valuable to you, and you can negotiate accordingly. If a production site is not really valuable to you, then you can also negotiate it accordingly, or you can maybe shut it down. So it also happened as well. One of the production sites had the financial difficulty, and this company was thinking if they should save them or they should let it go, and the model said let it go, because it wasn't profitable to keep it. And also the optimization provides a benchmark so that you can test your own models and then see how you're doing accordingly. And there are also lots of tactical analysis. You can change the production capacities, examine the effects of forecast variability, evaluate different transportation alternatives, and etc. That was the logistic problem. And the next one is I'd like to talk about security queuing analysis at the Vancouver International Airport. So here, this is basically the pre-board screening. So after you check in your luggages, you go to the security, right? So you line up over here, and each color represents passengers with different number of bags to carry on back. So what you do is you go through a metal detector, and then you have to put your bags into X-ray. If there's any problem at the end, the people, attendants search you for your bag, and they may use some machines, and then at the end you are cleared and you can leave. So but you can't leave before your bag, and your bag cannot leave before you. So the idea here is this project was just done like about a while ago, and then the problem was the airport was facing so very long lineups. The wait at the airport was almost like a few hours, and the airport wanted to do something about it. So, and the project goal was provide recommendations about required staffing levels to meet target service level for different passenger volumes. And during the project, we determined a target service level. So we said 90% of the passengers will go through the system in less than 10 minutes. And in order to achieve this, what we came up with, we implemented this schematic over here. We have the service time data, such as we collected data on how long does it take to go through the security, how long does it take to X-ray a bag, how long does it take to go to a bag search, and etc. And we also estimated how many passengers are coming into their flights. So we had the flight schedule, we had load factors, and we tried to come up with an idea that how early each passenger is going to come to the airport, depending on if the flight is domestic or international. And after that, we built a simulation model. After validation of the model, we ran lots of analysis and scenarios, and we came up with the optimal staffing levels. So if you have 10 people, what would be the best way to allocate those people into those security lines? So one common idea was if you have 10 people, then they were opening all the lines with 2 people. But we showed that this is not good, because then you put one person to the metal detector and one person to the X-ray. But then if a bag is being searched, one of the positions has to be left, and that line is blocked. So what we showed by simulation model is if you have 10 people, the optimal thing to do is actually opening on the 2 lines and put 3 people for search. That will increase the throughput. And after that, we also came up with a shift schedule model. So the data that we collected, we spent at the airport maybe several weeks, at least like 16 hours a day, and then collected different service times, such as X-ray, manual search, metal detector. We searched what will be the ratios for passengers who would have laptops and having searches and etc. And we validated the model. after we built the model, we came up with this chart. So this chart is what it tells you is on the x-axis, you see the total number of staff. And on the y-axis, you see the total searches and wonders. So here, for example, let's look at 20. So if I have 20 people to have agents, then for me, it's optimal to have 3 lines. And I should distribute them 5, 5, and 4. And each line is already including one X-ray attendant and one walkthrough attendant. So we have like 6 additional people there. So if you have 21 people, so you still have three lines. But if you come to 24, then it's optimal to have 4 lines. And now, again, we can continue. 25 is 4. But if you jump to about maybe say 32 or 30, then you are opening the next line, so you have 5 lines. So this is basically telling you, depending on how many people that you should have, then what should be the optimal staff allocation. And the next question is how to determine 30 is a good number for the passenger volume. We also came up with a formula that determines if you have, say, 500 passengers coming in the next hour, then you should have 30 people. If you have 550, then you should have 34 people. So we came up with a rule as well, and at the end we combined them all to come up with a shift schedule. The only remaining puzzle was how to predict the passenger volume. And for that, we developed a methodology by using load factors and flight schedules and a triangular distribution. So the idea is if you have a flight leaving in 3 hours, 10 o'clock, some passengers will come to the airport around 7. Some passengers will come around 10:30. They're going to be late. So, and then there will be, and most passengers will come maybe 2 hours in advance. So, and then that's approximated the schedule very well. And we generated a passenger generator tool. So that was basically a predictive model to determine how many passengers are coming in. Now everything is in place. Why? Because we know how many passengers are coming in. Then we know how many people that we are going to need for agents. And then we know how to allocate it to satisfy our service criteria. And the final piece was to do shift scheduling. So you can't really call somebody half an hour for the airport. So if they come to the airport, they may need to work, say, 4-hour shifts, 6-hour shifts, 8-hour shifts. So if the blue is target is how many people that you should have for every 10 minutes, then the gray area is basically what should be your shift schedule that will cover all the requirement. So the project received very well. So they did most of the changes and implemented the recommendations. We start new projects with them. Vancouver Airport is ranked always very well with the surveys, and the project got lots of media coverage as well. So I believe I can maybe talk one more project in the remaining time. So it's about in healthcare. So it's managing surgical wait lists for a Canadian health authority. So here you can think of health authority as consisting of different hospitals. So we have, in this case, we had 13 hospitals, and we have surgical demand, so demand for surgeries, and we had different specialties. So you have cardiac surgery, orthopedic surgery, eye surgeries. Each surgery have a different priority, and then we also have emergency surgeries or elective surgeries. And what will be the output? Output will be, you know, how much you are utilizing your resources, and how many people are still waiting at the wait list, and what are the waiting times for surgeries. So one of the questions we try to look at is like, what happens if we try to change resources between different hospitals? For example, you increase the beds of intensive care units, ICU beds in one hospital, and you close one of the operating rooms in another hospital and see the effect of wait time for different types of patients. And another idea was if you get more demand from different health authorities, what will be the best way to allocate them to different hospitals? So, and after doing the analysis, we found out that everything came from OR block schedule. So OR is, in this case, stands for operating room. And here you see different days of the week, Monday, Tuesday, Wednesday to Friday. And you have different operating rooms, 1 to 9. And if, for example, here on Monday in operating room 1, you have neurosurgeries. On Tuesday, you have dental surgeries. On Wednesday, you have plastic surgeries. On Friday, you have nothing because that operating room is not working that day. Usually we have these empty places because we don't have enough funding to run that operating room, or maybe there's no need. And you can see that cardiac always their own room, and orthopedics is always running because it's very busy. So the idea is this basically runs the hospital, that determines the bed utilization, resource utilization, and everything. So our question was, can we come up with a better OR block schedule so that we can minimize the resource utilization? So what happens to the patients is, once they have a surgery, if it's an acute surgery, then they have to go to special care units such as ICU. If they had a heart surgery, they have to spend few days in an ICU unit. Then they go to a hospital bed, we call it ward, and from ward they can go home. Or they can go to ward directly and go home. Or if it's a day surgery, for example, you have your surgery, you spend maybe a few hours recovering, and then they send you home immediately. So what's the data look like? So data, we had different specialties, cardiac or orthopedics. We have different procedures. Each procedure had a different priority, and each priority has a different wait lists, number of people waiting to have surgeries. Each surgery is going to have a different time, like 240 minutes, 60 minutes, and what type of operating room is required. For example, you can't do cardiac surgeries in another room. It has to be a certain room. And after this, we have the information about length of stay in ICU units and the ward and the chances that they're going to stay there. So the idea here, you have a bunch of group of surgeries here, and you allocate them into different hospitals, right? So and then if you have a certain type of surgery, maybe you put them hospital 2 on Wednesday in operating room 5. So we had to decide for each block, on hospital for operating room O, for surgery type S, for a day of the week, if 1 or 0. So that was our decision for each type of different surgeries. And then what happens is, once you make those decisions, each hospital will have certain operating rooms and certain beds. The wait list will be applied. You apply to the resources, and at the end, you get your throughput, number of surgeries performed on each specialty. And we had the optimization model again. In this case, the objective was minimizing the maximum in bed utilization, or we can think of minimize the peaks in bed utilization. And I think this is going to be clear in the next slide or so. And we had constraints such as, each OR block in a day should be one specialty, so specialists cannot share a certain block. And we wanted to have a simple schedule, so we wanted to have the same schedule at least for 4 weeks. And we had capacity constraints, such as surgeons cannot be working on 2 operating rooms at the same time. We have number of beds available, so we have limited capacity, and then operating room time is also limited resource. And as I said before, some compatibility of OR specialty. For example, you can't put a cardiac surgeon on a different room, so it has to be a certain room. And we had some target throughput that we like to satisfy. So after you build the model, before you build the model, this was what the picture looked like. So this graph shows number of beds used. On the y-axis, you have number of beds, so you see about 60 to 75, and you see a cyclic pattern. So the pattern has been repeating itself. And on the x-axis, you say different weeks. So week 1, week 2, week 3, and you have different days of the week. And this is very classical for almost all hospitals. So the hospitals weekends are usually less busy, and on Monday it starts to get busy, and on Wednesday or Thursday it gets really busy, then it goes down again. But here, if you plan for it, then you have to have 75 beds, and you have to have it operational. But what the model can do is, once we run the model will be able to actually could provide the red line. So what it does is it minimizes the peaks happening in these mountains over here. So it pushes on top of them so that the schedule will be more smooth. That means we could save like about 7 beds. So instead of staffing for 75 beds, now we could schedule for 68 beds. So that's a huge savings, because each bed is associated with number of nurses and doctors 24/7. So it comes like a really affects the bottom line of a hospital. So the model will be able to actually achieve the same throughput with less resources by just putting the blocks in different places. So let me show you the initial block at the top and optimized block in the bottom. So if you look at it, you won't be able to see any difference in terms of operations done. The only thing is where the blocks are, because some surgeries are more compatible than the others. So that if, for example, if you put a cardiac surgery on Monday, because the patient is going to stay in the hospital, it may be better to put the cardiac surgery on Thursday or Friday. So, and then different operating specialties go better with each other. So the model is putting them at the best places. So it's exactly the same number of blocks. So what we also did is we also tried to optimize the model again now by just seeing how much more surgeries we can do by using the same number of 75 beds. And in this case, what we can achieve is we can achieve one more operating room. We can add one more block to the schedule and still be under 75 beds. So the model can be considered either as getting more surgeries done with the available resources, or you can do the same amount of surgeries but using less resources. So your preferences. The model is quite capable of doing that. So I think that I'm going to stop here. There are some references with some of the projects I mentioned. There are the links if you are interested in reading it, and most of them are available on my website. And this is my coordinates. Thank you very much. I'm open to any questions and comments.
Well, thank you very much, Professor Mehmet. And folks, we are now open for question and answers. So if you have any questions, you could either insert your questions in the question box or equally raise your hand. There's a hand icon available on the webinar console, so please click on it if you want to talk to the professor. So we have a couple of questions in the box. The first one, how can one start learning analytics?
Okay, so one way that we teach analytics at Ivy, and we also took the Harvard model, is we use case studies. So case studies are usually a few pages long. They describe a problem, a company situation. The case studies also come with some data, and at the end, the students are expected to come up with some solutions. So I think if you have some background in analytics, I think this will be the best way to get to know new skills, such as maybe a case study on a simulation, a case study on optimization. And what happens is everybody works on the case studies themselves, and then we meet in a classroom and we discuss the case study together. That's where the big learning happens. And usually we have a student or somebody to come forward and then present the model, and then maybe somebody else is critiquing their model. At the end, the teacher usually shows a more correct model, and then we'll have to make a decision at the end. And next class, we do a different case. So this would be one way to get started. Another way could be just reading more articles about it. But I think somebody has to have some certain foundation about some maybe mathematics or analytics to build on it. And if you don't have any, one easy way to is just to learn and do some case studies.
Thank you very much. We have another question in the box. What is the role of data for models? What if no data is available?
Okay, so data is very important for models because there's a famous saying, garbage in, garbage out. So if you don't have the right data for the right model, then you won't be able to get the results that you want. So it's very critical, I think, for organizations to, if they're going to be using analytics, it's good practice to get started collecting good data from the beginning. For example, for hospitals, they collect great data on clinical data, such as how the patient is doing, all the different tests and etc. They also collect very good data for accounting reasons because they're going to charge the government or insurance companies, but they don't collect good data on operations. So we don't know how long does it take to have a certain surgery, how long does it take to get patients from one place to another. So in most of the time when we do projects, we struggle to find the right data. We try to use proxies for it, or sometimes we just collect it ourselves. So the data is critical. Having said that, and some of the projects we've done, and I should say one of the most successful projects, we did it without any data. And the reason was the following. So we built a model as if we had the data. We've put some fake data to it. and we showed the company how the data could be useful. And they showed the potential how the model could be useful, so they started collecting the data. That's one benefit. And sometimes another benefit is you can build a model without any data, but you can ask experts their best guesses, and you can start putting into those things, and then try to run the model with sensitivity analysis and determine which data is more critical to you. And sometimes some data points are not really matter. So if they are twice as much or 3 times as much, it won't change the outcome. But there is always 1 or 2 parameters that's really critical. And the model helps you to determine that without actually knowing the correct values. So what you can do is, if you identify the top 3 critical values in your model, you can just go ahead and try to collect more data to it and maybe measure it and collect it so that you can still get some value even though you don't have any data from a model.
All right, thank you very much. And we have one last question. How can an organization start practicing analytics?
So I think the first step would be try to collect data, because if you can measure it, you can really compare it, right? So I think the first thing is try to collect data at critical things. The second thing is trying to understand how you are doing, trying to establish certain benchmark. It could be number of sales per week, number of sales per month, year, resource utilization, number of customer complaints, number of employee complaints, things like that. So you have to collect some data and some measures. Try to develop some performance measures, and then you try keep track of it, so that at least you establish a baseline. Once you have a baseline, then you can see how to improve it. This could be maybe building a model and trying different things. This will be maybe trying different strategies. But if you don't have those measures, then you won't be able to judge how you are doing compared to your base case. So I would recommend to start with the base case, establishing the base case, start collecting data, and start developing some performance measures, like maybe key performance indicators. They call it KPIs, and you can establish a dashboard to get started to measure how the company is doing, and go from there.
Okay, thank you very much, Professor Mehmet. That really brings us towards the end of the webinar. Any concluding remarks that you would like to give before we dismiss out?
I thank you for this opportunity. It was a pleasure to do it, and if I will be happy to answer any questions if received later by email or phone calls. And thanks for the opportunity.
Thank you very much once again, and I really want to thank you on behalf of the Madinah Institute for Leadership and Entrepreneurship for taking the time to deliver this live webinar. So once again, thank you very much, Professor Mehmet, and thank you all of those who attended this webinar. We are recording it. Please stay tuned to webinar.mile.org to learn about our upcoming programs and webinars, and to equally access the recorded versions. With that note, I would like to end and conclude. So you all have a good day, good afternoon, good evening, wherever you're calling from. Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you very much.
Wa alaikum salam. Bye.